Hello again. I'm just trying to create an update here on the fuel oil calculations so everyone feels comfortable doing them. I thought I'd come up with an example that I've done before. This would allude to the diagrammatic diagram that I gave you, or video that I gave you earlier. So I'm going to tell you a little bit about the ship that I'm designing a fuel system for. Again, I'm keeping this very simplistic. So I'm using a tanker, and my ship would be using HFO for fuel. My ship has a total of 3,750 cubic meters, and it has a settling tank size of 42 meters cube. And the time to fill all the tanks from empty is approximately 8 hours. Now, I chose this number based on my ship. Of course, this would be individual to what your ship is. Please keep in mind when you're doing these calculations, you may find later on that the value you put in was a little different than what is in real life, but that's okay. Use a number that you think is going to be fine. Normally, the time to take fuel on does not exceed 12 hours. 12 hours would be for big ships that are taking 12 hours to unload, but keep in mind somebody's on watch while you're doing that. And the last little piece to give you information on now is the time to fill the settling tanks. If you remember from class, I had mentioned that this could take anywhere from a half hour to 2 hours. I'm using 2 hours as a point of convenience. Now, one of the things I want to highlight that when we do these calculations, you have to look for the velocities of the fluid you're using. Or when we look at the formula, Q equals VA, the V I'm looking for is the fluid velocity. On your D2L page, you will find a sheet like this that is available, and this is called the SNAME Fluids for Velocities. This is taken out of the marine engineering book, but I've put it online for you guys. So in my case, what I'm doing is I'm looking for fuel oil transfer suction. So I'm going to just draw a line across here. I'm using this number because in this particular setup, fuel oil is HFO. I'm also looking at for transfer. So it's giving me these two numbers, 1.8 and 4.6 meters per second. So you'll note that I've put these numbers here. I also want you to pay attention that these numbers are in meters per second. If you're using diesel fuel as your setup, notice that there's a separate line over here for diesel. So diesel would use for the suction 2.1 meters per second, and for the discharge it would use 3.7. Now, of course, if we're going to use our same pipes for both suction and discharge, we will have to calculate both and use the largest. So how I'm going to set this up initially is I'm going to show you how to calculate using your fuel setup, finding the area that we need to move this through, and eventually give you a pipe size. So first of all, I'm going to try for the bunkering lines. Now, I know my hand is in the way, so I'll give you a few minutes. This is the best video setup I could create with my limited tripods. So bunkering lines are the lines that basically bring the fuel into the ship. So on our diagrammatic, it would have looked sort of like this. And remember, we have international flanges, port and starboard. Now this would feed into our manifold. Okay, so we're looking for the pipe sizes for these lines, and these lines are typically all the same size. So in my setup here, I'm going to take my total time and my total fuel on board to come up with a Q. So in this case, Q is equal to 3,750 meters cubed over my time, which I said I was going to take bunkers on, which is 8 hours. This, in turn, gives me a Q of 468.75 meters cubed per hour. Now that I've got that information, I can utilize this formula to come up with a pipe size. So now I'm going to use the formula Q equals VA, and I'm looking for A. I need to find V. So when we look at this, if we were trying to assess, is this a suction or is this a discharge? This would be considered on the discharge side because remember the pump is on the shore side and it is pushing the fuel on. So in this case, my V I'm going to use is 4.6 meters per second. Okay, so now I have Q being equal to 468.75 meters cubed per hour, and that is going to equal 4.6, and that's meters per second, so I'm going to multiply that by 3,600 seconds in an hour, okay? And then I'm going to come up with A. So what that looks like is A is now going to be equal to 46,875 over 16,560, and my A value now is going to be 0.0283 meters meters squared, because this value now is an area. So I'm just going to let you get those numbers, and if you want to check it in your calculator to make sure I've got the right numbers put in there, please feel free to do so. When we have A, we can now find the diameter of our pipe that we want to use. So the diameter of this particular pipe is going to look like this. D is equal to the square root of 4A over pi. Okay, so I've just transposed the area formula, but you can use this as well. So when I have this information together, I am looking for D. Now keep in mind too, my number right now is in meters squared. Pipes are generally sized in millimeters, so I'll go to that in a few seconds. So when I'm looking at this D, what I'm trying to calculate for now by putting the values in is that D in this case is going to be equal to 4 times 0.0283 meters squared, and I'm going to divide that by pi, and my answer that I'm going to get for D is going to be equal to 0.1898 meters, okay, which equates to 189.8 millimeters. Okay, so what I'm trying to look for now so I can size these pipes and put that on my diagrammatic is what is the nominal pipe size. Okay, so how we look for that is, again, we go on to our D2L page and we find a chart that looks like this. So you guys have all seen this before. I went through it in class, and what I'm trying to look for here is, remember, most of my piping is going to be Schedule 40. Okay, Schedule 40 is also considered standard piping. So I'm going to look for something that's in the vicinity of 189 millimeters. I'm just looking at the time here. And when I look at this, I can see that 175 or 7-inch pipe is in the vicinity, but I'm looking closer at 8-inch pipe. I go down to my standard and I see here that right across here I have a pipe size that I can use. So this would fit standard pipe, in this case a little larger than what I would need, but will be adequate, because if I use the first one up, the standard pipe is a little bit too small. It's 178. Now I know it's very difficult for you guys to see that, but I want you to try this on your own. So in this particular scenario, I would use an NPS of 200 millimeters. So when I put that on my diagram, that would say 200, 200, and 200 right here. And that is how we size the bunkering lines. I will update you again shortly for how to create sizes of piping for our transfer lines. Thanks.